webinar today. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, salam sehat untuk kita semua. Good afternoon, Mr. Joseph from Singapore. Yeah. So today webinar, I'm very happy because at the first time we will discuss about the new product of the synthetic aperture radar that are available in the market according to the brochure. Yeah. So thank you very much for the ICEYE to give a chance for us to disseminate their product. Yeah. According to the brochure that said the ICEYE is the synthetic aperture radar with the 50 centimeter spatial resolution. So I think it's very interesting. And also the most important thing according to the brochure is the temporal resolution. They said the data will be available after 8 hours or something. I think it's very good for the remote sensing society like us, yeah, because recently we have data freely available from Copernicus, Sentinel project, Sentinel-1 or Sentinel-2 or Sentinel-5, yeah, and then we can utilize all the data for our applications. So this afternoon, MAPIN or Masyarakat Ahli Penginderaan Jauh Indonesia or Indonesian Society for Remote Sensing will conduct a webinar that invite two prominent speakers. The first one is Dr. Laila from the Institut Teknologi Sepuluh Nopember. She's expert in the synthetic aperture radar application. So I think we will have a very insight or very future insight for SAR application. And she's very active in the SAR research and also for the deformation application or something. So we hope Bu Laila will discuss or will give some insight or some another perspective related to the synthetic aperture radar. And then the second speaker, we thank to Joseph Ow Yong from ICEYE, yeah, to give a chance for us to know more in detail related to the ICEYE product. So I think it's very good for us today, yeah, to have a fruitful discussion. And also I would like to thank to the participants today, especially Pak Hardi Kusalamwardi from Dewan Geospasial Indonesia or DGI. He's our senior member of the MAPIN, and he's also interested for the many application of remote sensing and geomatics engineering. So I think after the presentation for the two prominent speakers, we hope we can discuss the future of remote sensing and geospatial information technology. So for that reason, I would like to open this webinar by saying Bismillahirrahmanirrahim. Dengan ini webinar ke-20 MAPIN tentang synthetic aperture radar dan produk dari ICEYE dengan resmi dibuka. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Waalaikumsalam
warahmatullahi wabarakatuh. Thank you, Dr. Agustan, for opening this session. And the next agenda, without any further ado, will be moderated by Dr. Ilham. Dr. Ilham is a lecturer at Universitas Hasanuddin Makassar, and also he is a chairperson of Indonesia Society for Remote Sensing at South Sulawesi. And please welcome Dr. Ilham Alimuddin. Screen and time is yours.
Right. Thank you, moderator. Thank you, MC, Mbak Zilda. Assalamualaikum warahmatullahi wabarakatuh. Peace be upon all of us. Dan selamat siang, salam sejahtera buat kita semua. Ladies and gentlemen, it is an honor for me again as an assignment from my boss, from the chairman of the chairman of this MAPIN, Masyarakat Ahli Penginderaan Jauh, ya, the Remote Sensing Expert Association. I am based in Makassar, actually, in South Sulawesi, but now, right now, I am visiting Jakarta. So I am live from Jakarta, it is really an honor again to participating in this 20th. Yeah, this is the 20th time that we are having this kind of webinar. And for this opportunity, we having ICEYE as our partner of discussing the synthetic apparatus radar satellites and applications. We're looking at a new space perspective by having this collaboration with MAPIN, with the Indonesian Society for Remote Sensing. We have two speakers for our event today. As Pa Agustan, our chairman, has mentioned in the opening, we have Ibu Noorlaila Hayati from ITS, Institut Teknologi Sepuluh Nopember Surabaya. I happen to know her myself, and we've met sometime during our study in Chiba, Japan, and I believe she graduated from German university as well, based on her degree. And there will be another speaker. Of course, this is our partner, Mr. Joseph Ow Yong. Later, I will introduce him because according to our orders, they are the speakers. Ibu Leila will speak first, I believe, as a general overview of what synthetic apparatus first. And later, Mr. Joseph Ow Yong will be specifically also will focus on SAR, but more on what ICEYE. That's how it's pronounced. I was trying to Google this company, and it is that how it's pronounced, ICEYE. Yeah? So the I is on the ice, something like that. Anyway, we are delighted to have this event, and I believe the participants are coming. Yeah, although so far we have around 40 participants, but usually it's like this. When it started, we have a few, then along our webinars, then participants flowing coming into our room. So that's it. I would start our presentation, our speakers today. We'll start with Ibu Noorlaila Hayati first. If I can share her profile a little bit, I will do that also for Mr. Joseph. Ibu Leila's more focusedly on the deformation studies on using interferometric SAR. And I believe because of that study, Ibu Leila has been involving a lot of research related to the SAR application. So we know that we have one of the experts in SAR to give us insight of this technology. So not much on her personal that I know her. She's a lecturer in ITS Surabaya, and I believe she will tell us more later on her research and share on her expertise. So ladies and gentlemen, please welcome Ibu Noorlaila Hayati to give her presentation. You can share your presentation material, Ibu Leila. Time is yours.
Thank you, Pak Ilham. Before I'm going to the presentations, I maybe a little bit thank you for the Pak Ilham give me some sweet introductions, and also I want to say hello for the first boss. It's the head of the MAPIN, and then the second boss also Pak Ilham, because I'm just a member of MAPIN. So I think that you are both of you. It's a boss of MAPIN. And then also say hello for the Mr. Joseph. Maybe this is for me that the first ones that I know you, and then that I already also a little bit research about this ICEYE or ICEYE. I don't know what is this, the truth spelling, but maybe Mr. Joseph can give the truth spelling for this one. Okay. Yeah. So now before we are going to the main purpose of these presentations, which is we want to know the new satellites of the SAR, maybe I will just introduce you about the applications of synthetic aperture radar. as we can see that now not only in Indonesia but for also in other countries, it's already used the synthetic aperture radar for many years, maybe 10 or 20 years, which is maybe the first ones that I know it's in 1993. There is a good publications in the Nature about the earthquake that is can be monitored with the INSAR. So for these applications, so maybe it's not all of the applications that I can give you for this webinar. Maybe it's just one of the applications in the geohazard monitoring, or another applications that is still related to monitor the Earth. But mostly for SAR application that maybe the audience in here already know about how the applications of INSAR can be used for the cosmic deformations. Maybe it's caused by the earthquake or another seismic activities, or maybe we know in Indonesia it's kind of viral or highlight in this couple of weeks, because there is a volcano eruptions in the 4th December, and it's in the Mount Semeru. And there is also applications of the INSAR due to some subsidence phenomenon. And for this subsidence, we can say also there are a lot of causity why the subsidence can occur in some area. Maybe the first ones, it can be from the fluid withdrawal, or from the hydrocarbon productions, or maybe there is some anthropological activities such as land use change or peatland fires that is occur in this area and then affect the land and then going to the subside for this surface. Another applications that is not for the natural hazards, we can also use INSAR to create an alternative for elevations model. So maybe you know that there are a lot of observations or measurements to create this digital elevations model. And one of the observations or one of the technique, we can also use the SAR. And another one, if we just use the amplitude image or the amplitude informations in the SAR, then we can also observe some fluid monitoring that maybe occur in some area. That is maybe one of the example in the South Kalimantan. So we have some also fluid monitoring due to the intensity of the rainfall or so on. And the last one that not least, it's the ones that is really booming now. Maybe it's just like 3 years ago that INSAR can be also to monitor the weather modeling or the weather or the climate change, which is one of the informations that we can extract with this delay is the precipitable water vapor. So we are going to the first applications, which is the cosmic deformations. One of the good prints that we can see, it's in the left side. It is the prints that can be occurred, that is occurred due to the Hector mine earthquake in the 1999. It's in the USA. So using the satellite ERS, we can see that the INSAR have measured that how much deformations occur in this area, and then you know that for this INSAR we use the oblique view, so it is in the 1 dimensions. But because we know also it is one of the drawback actually for the SAR, yeah, because we just have to see in the line of sight. But if we have 2 orbits or 2 directions, and maybe use another advanced technique such as multiple aperture interferometry, then we can create the good decompositions of 3D displacements in this area. Of course, with these informations of deformation that occur in the area, maybe with some tectonic informations or geological information, we can measure quantitatively what's going on in this area, how much the deformations occur in this area. So this is in the 1999, so it's a little bit few throwbacks in a couple of years. And the most maybe recent, maybe 3 or 4 years ago, we have also Lombok earthquake that is occurred in 2018. And we can see also here, both in the ascending and also in the descending, we get also good prints that is occur in this area. And if we make some decompositions just for 2 orbits, then we can create the 2D displacements in this area, which is the vertical displacement and also the X and Y displacements. And we can see here in the north of the area of Lombok, there are some effect of deformations. It's about 25 centimeter. And then the movement in the horizontal, but it's not for Y directions, not just for X directions. We can see there are some area that is moving to the east and moving to the west. So this is the short example how we use the INSAR to monitor the co-seismic deformations, such as during the earthquake. And the second one, this is really exciting monitoring actually when we measure the volcano deformations. Unfortunately, I didn't process, have not yet processed the newest one. So this is one of research from my team in the ITS, how we measure the time series that is going on with the behavior of the Sumeru. And when we see in this crater, there are some pattern that maybe it's a little bit smoothing, but we can see here in the trend of mathematical model in the polynomial, actually before there is an eruptions in the 1st until 16 April 2020, there is some behavior that we can learn actually. So in the July until November 2019, this deformations is like we have some pattern of inflations, and then starting in the first year of 2020, we have some like a deflations patterns. And when we know that there's the peak point of this pattern, then we can see that maybe the Mount Semeru will have something that they want to blast or get out the materials. Then it can be proved also in the first and the second week of the April. There is an eruptions going on in this mount, and we can see that it's going to the down again for the pattern of this polynomial, and then we can see that it is just a really rough predictions that maybe if there is a behavior like this ones, and then in the future there is something going on when they want to go to the deflations again, and it can be one of the interpretations, it might be erupted or something like that. So I use this time series using leak S-bus processing. This is the ones that maybe from the Copernicus and also from the Cosmic, from the Leeds University, and also from another consortium in the United Kingdom that make this open source. So you are in this audience, I can say that it's relatively easy to use this processing. So if you also want to use INSAR for the monitoring, at least for the Copernicus data, such as Sentinel-1, you can use the leak S-bus processing. Okay, another one applications is also about the land subsidence. This is one of the example due to the hydrocarbon productions, which is a geothermal. So we know that in Mexico, there are one of the famous geothermal factory. It's in the Cerro Prieto. And then we can see that is there any phenomenon that occur when this geothermal extractions from the deep inside the earth and then going to the up down, and we can see is there any effect for the surface in here or not. And one of the technique that we can use to know directly of this effect we can use the insert technique, or maybe in some small baseline or time series insert technique. And it's just for 6 months, we can see precisely how much the deformations or the subsidence occur in this factory. And we can see here with some animations in the left side that for 6 months, it's occur maybe about 6 centimeter. So we, you know that it's really important to know the deformations or the subsidence, because it is related with the factory. So if there is something that in the infrastructure of the building, it's going wrong with this effect of subsidence, then it can be have so many hazards in the future. So the monitoring with this INSAR, we can mitigate or maybe avoid something that is going to happen in the future. Okay, another one, it's also maybe it's recently occurred in the Sidoarjo, not in the Lapindo, but in another village. So there are 2 villages in the Sidoarjo. That is always in the rainy seasons, the area always get flood, and then the inundations of the water, it's not just disappear for 1 day or 2 days, but it can be remain for this inundations water until 2 months. So for this phenomenon, we can see there is something wrong actually with this area. It's not just the cause of the intensity of the rainfall, but maybe there is also some phenomenon that makes this area, it's like a ball of land. So we can measure with the historical analysis of the INSAR. When we use the time series, maybe between 2016 until 2020, we can see actually in the historical what's going on in this area. And now with the INSAR, we can predict and we expect, actually not predict anymore, expect that the subsidence occur in the early of 2018. And then when we ask the netizens in this area, the flooding actually it's occur in the 2018. So it's really correlated with the subsidence that also occur in these 2 villages. So for your information, these 2 villages not exactly in the Lumpur Lapindo, but it's still near to the Lumpur Lapindo. So it's in the Kudung Banten and Sidoarjo. So some local governments maybe have some suggestion what's going on with these anthropological activities. It might there is some groundwater extractions, or maybe some fluid extractions or gas that is occur. The factory it's located in these 2 villages. So it's the 2 villages actually it's in the located in this ball of subsidence. So it makes that the flooding it's cannot be so the water point going from the outside of the rainfall cannot go directly to the river, but it's just inundate this area. And then we also have some fruit or ground truth also that there are many houses that get affected by subsidence. As you can see here in the middle of the picture, it's really funny actually, but it's also sad that you know that now this is the door and this is also the window, and you can see that the door it's just maybe remain 1 meter, and another one it's already buried in the surface. So this one it's really evidence of the subsidence occur in this area. Okay, now we can also go to the some applications of subsidence that is have double negative effects. As you can see here, this it is located in the South Kalimantan, and then you know that the Kalimantan island it's mostly covered with the peatland, And you can see here that in Kalimantan, there are a lot of trouble or a lot of problem with the environmental monitoring. And then you can see here, one of them is due to the land use change or due to the explorations of the hydrocarbon, and also due to the fires. And you can see here in the top, there is a subsidence occur in the north and also in the south. As you can see, the subsidence rate is quite different between north and between two sources. And then we compare the depth of the peatland in the north area, and we can see that fortunately the depth of the peatland is still good. I mean, our team found that there are 70 centimeters the depth of the peatland, and some area also have more than 1 meter. But unfortunately, the south area, which is have a high subsidence rate, the depth of the peatland is quite pure. We can see here that the depth of the peatland is just like 4 centimeter. Even the worst in the west area, it's just like 1 or 2 centimeters. And you know that the ones that I said before, it is have double effects, because you know that the peatland has a carbon content. And if there is some subsidence occur in this peatland area, and then when we also know the peat bulk density and carbon content in this area, then it can contribute directly with the CO emissions. And this is one of the goals in the sustainable development, that how to reduce the CO emissions, but you know that actually one of them can be contribute with the subsidence that occur in the peatland. So with the INSAR, again with the SAR technique, we can measure actually and estimate how much CO emissions can be exist when the area has subsidence, and of course with the area that is covered or have a layer of the peatland. Okay. And another one is besides of the geohazard monitoring, we can also use SAR to create a digital elevations model. This is one of the example in the Mount Bromo, Indonesia. We use alus pulsar technique with just 2 SAR images, and then we coupling with the master and then slab with short temporal baseline, and then good enough perpendicular baseline, not really small and not near to the critical baselines. We can also create the digital elevation model as an alternative to know the updated elevation model in the area. And then we make some comparisons with the SRTM, and you know that here in this graphic that the SRTM is quite smooth than the INSAR, and INSAR is a little bit detailed in the contour or in the elevations or in the topography of this area. So this is one of the alternative also when we want to know the updated of elevations model in the area, because you know that the constellations of SAR satellites, it's going maybe for 6 days or 12 days for each day. So you can use this alternative when you want to know the elevation model in the area. Okay. Now, we can also take benefit of the amplitude image in the synthetic aperture radar. So this is one of the case study. It's in the South Kalimantan again, and you know that in the first week of January 2021, there are a huge flood that is occur in this one province of the South Kalimantan. And when we can extract the permanent water and then measure the before and the after this flooding, then we can estimate how much area that is inundated with this flooding. And when we take a comparisons with the participatory map from the government of South Kalimantan. So there are some netizens send some geotagging photos that the area or their house has got affected by the flooding. Then they send to the government of South Kalimantan, and then they make some mapping which area that is affected by the flooding. And when we compare with the estimated from the SAR amplitude extractions, we can see that this area is close enough with the ones that in the participatory map. Okay, so the last ones, this is the ones that it's really my research now. So how to use the INSAR? It's not just only to measure the deformations or maybe to create elevations model. However, now with the new development, we can also use INSAR to monitor or to estimate the precipitable water vapor. So it's just maybe some really short theory about INSAR. So we know that in the interferometric phase, we have many signals. It's not only for the deformations, but there is also the unwanted signal, such as the topographic phase component. There is also the propagation delay in the tropospheric, and then the propagation delay in the ionospheric. There is also a phase component due to the inaccuracy of the satellite orbit, or maybe the uncertainties in the Earth ellipsoidal reference surface, or maybe there is a noise due to the system thermal noise or due to the loss of coherence between two images. Now, the idea of to get this water vapor actually when we can reduce or eliminate all of the unwanted signal, which is I mark with the red color, and then when we also assume in the area we know already the subsidence rate in the area, or maybe we can assume that there is no subsidence occur in the area, then we can say that the remain interferometric phase in this information, it's just the propagation delay in the tropospheric layer. And then with this some computations of modeling to convert these components in this delay into the zenith wet delay, and after that we can also compute furthermore to the short wavelength zenith wet delay. So in the left picture, this is some time series of the zenith wet delay that is occur in the Surabaya. So it's in my home university area, and we can see that we did many epochs in this area to observe the zenith wet delay, and after that we compare and then integrate with other measurements, such as we can use the GPS observation to get the long wavelength. We can use also from the spectrometer, such as from the MODIS or from the NOAA satellites, or we can also combine with the numerical weather modeling. So here we have some nice animations about the precipitable water vapor that is occur in Surabaya. So you can see here with 12 days difference, we can see the spatially distributed of the water vapor in the area of Surabaya. Okay, so that's all of the applications that we can use, that we can take benefit of the INSAR technique. And you know that all of them has to be processed by the SAR image. And in this picture, you know that there are a lot of famous SAR data, such as in the L-band we have like ALOS, JERS, or maybe in the C-band we have Sentinel-1A, RadarSat, or maybe the previous satellites such as ERS and RadarSat. And the X-band, we also have like TerraSAR X and then Cosmos Sky Map. And now we have really nice new satellite constellations, ICEYE, and then correct me if I'm wrong. I hope that it is right that it is available from the 2019, and maybe for the revisit days, I just do some research. It's maybe like 16 and 18 days, but maybe the ones that Pak Agustan said before, that it can be also turned on to be in the couple of hours. Maybe a detailed explanation about ICEYE can be go to the Mr. Joseph, which is maybe expert with these satellites. Okay, I think that's enough for me. This is the ones that I can show you about the applications. Thank you very much.
Thank you. Thank you very much, Ibu Noorlaila Hayati. We should give her claps for her presentation. Very not only entertaining, but at least it gives us insights on what the SAR application mostly. And as I said, that she talks a bit general, but in our second speaker, Mr. Joseph, will give us more on the applications on the SAR images based on the experience of this company called ICEYE. Ladies and gentlemen, so bear with me. We will be listening to the second presenter first before having the question and answer later. So those who will have a question, you can write down the chat box in our room, and we'll give you opportunity to raise hands as well if you want to ask at the question and answer session later. All right, we proceed on our second speaker. Thank you, Ibu Laila. It's a very nice lessons and also some examples of applications that you can share with us. Okay, now we move to our second presenter. Just let me show you a little bit of the profile of Pak Joseph, or Mr. Joseph, who is based in Singapore, I suppose, but he will tell you more on our webinar today. But just a little bit, what happened to this sharing? Okay, here we are. So he will tell a little bit of the ICEYE later, but Mr. Joseph is a regional manager, yeah, of this ICEYE, and he graduated from Royal Melbourne University, Royal Melbourne Institute of Technology. I'm sorry. I believe he's expert in satellite images, bring him to this company. But initially, he also worked with Bentley last time in the digital cities as an ASEAN product manager. He is also a senior sales executive in Planet in APAC, and he is also a sales director and at the company. And now he is a senior regional manager in ICEYE. So, ladies and gentlemen, please welcome Mr. Joseph Ow Yong. That's probably the pronunciation of his name. So we'll listen a lot more on application, because I opened this company. It has a lot of application on SAR images. Thank you. So time is yours. Half an hour, and more than that, it's okay. Go. It's your time.
Oh, thank you very much, Dr. Ilham. First of all, may I extend my thanks to the Indonesian Remote Sensing Society. This is certainly a great pleasure for ICEYE to come and present to you, first of all, what ICEYE is about, and then what hopefully we can do. So I'm going to, I guess, share my screen.
Yeah, sure. You can share your screen. I believe you already given permission to do so.
Okay. So just let me do that in a moment.
This also broadcasted in a YouTube channel, so people are also watching in the YouTube channel.
Ah, here it is. Okay.
Okay, slides are coming.
You can see my screen?
Yes, screen.
All
you
right.
just need to put it on the mode, presentation mode.
Yes, thank you very much. So before I begin, I guess, thank you so much again for the introduction. Thank you for having ICEYE be present with your very distinguished group of remote sensing experts. I must say it is definitely, I'm listening in awe of already, the previous presentation about how, you have actually done the various studies with the various kinds of synthetic aperture radar that's been around in the with the current incumbent providers of SAR data. My background is really in, if you can notice, it's about business development in particular with remote sensing and GIS products, as you have mentioned just now. And so currently in ICEYE, I'm the regional manager for business development in the APAC ASEAN. And today I'm really gonna also give you a rundown of what ICEYE, how it was formed and so on. Just a little bit of background, because I understand that some of you have not heard of ICEYE, in fact, how ICEYE came about and so on. And then we're going to delve into the ICEYE's approach, right? In terms of what is the difference it brings to the market, compared with the traditional providers and so on and so forth. And then we get into some of the, hopefully the new kinds of approaches that we bring because of our unique number of satellites, the constellation, and so on and so forth, okay? So ICEYE began, depending on which time you are referring to, as a very young startup, maybe perhaps like 10 years ago, and as a university technology development project. So we have our founders, university, experimenting and building up the technology, and then further developing it and improving the concepts of smaller equipment, smaller devices and systems that actually could perform with the same kind of fidelity as the existing kinds of satellite systems. So basically what you need to do is to develop systems with low power, but sufficient power enough to generate the kind of signal and backscatter return, and then collect the data and form that kind of radar image that's sufficient for analysis, right? And then it went on to operationalization in terms of launching a satellite. And then in 2018, the first operational satellite was launched, and today it's still working. And today we have quite a few more in our constellation. Here you see the image of the satellite in the test chamber. It's a much smaller version. This is the plus or minus 100 kilogram class of satellite. It's substantially smaller, therefore lighter, therefore less costly to launch, as you know. And in fact, this is the world's first synthetic aperture radar of this kind of size, right? And with the kind of size, it was still able to be performant enough. It had enough resolution, and I'll go through the modes of collection later. And so to be able to actually offer an alternative to the current number of providers, right, as to the synthetic aperture data that's coming down. So we started to launch a lot of satellites. Our last launch was in the 30th of June this year. We launched 4 satellites on the Falcon 9 EXO launch platform. And in the final analysis after June, we actually launched 14 satellites. So it's always exciting to see your satellite launched in space, especially when it's streamed with live video. So 14 satellites in June. this year. And by 2023, we expect to have launched about 18 plus satellites. So as it stands now, we're already the largest number of satellites in space operating. So all the 14 satellites are actually successfully launched. They're all operating. Some of them are owned by some of our customers. Some of them are demonstrators, and so on and so forth. But all of them are successful. And we are now embarking on a new kind of imaging capabilities, which I will touch on later on. And I think next year, we're going to launch our next generation satellites, which are leaps and bounds ahead of our first generation satellites, okay? Now, in this particular presentation, I'm just going to focus on a theme, which is persistent monitoring, right? Persistent monitoring is, I think, the kind of a new approach that we are embarking upon. And to do that, we're going to have to offer very high frequency data collection, right? Our satellites return to the same location very frequently. We have very high agility. We are able to take even multiple locations and targets from a single orbit. That's a possibility. Our satellites have got very, very high resolution as well. Later I'll go through that. High sensitivity so that you can detect the changes that you need to, and the coverage, right? So, Indonesia is a very, very large country. Approximately 2 million square kilometers for its landmass. And then also the capability to deliver very quickly to your users, right? Of course, all of you know, and that synthetic aperture radar can see through clouds. We even image at night if you want to. If you want to task an image at night, you can do that. And of course, it cuts through smoke and so on and so forth, clouds and rain. Now, our main offering as of last week consists of 3 modes of collection. One is the spot mode, which is a 5 by 5 kilometers square. Now, our spot size is 50 by 25 centimeters, but our ground resolution is roughly, when we process it out, right, is about 1 meter resolution, which is still very, very, very good. We have a strip mode, which is about 30 kilometers by 50 kilometers at 3 meters resolution. And then we have a scan mode, which is at about 100 kilometers by 100 kilometers, giving you 10,000 kilometers square. Now, all our satellites have this capability of switching between these 3 modes. And I referred to agility just now. What we mean by that is that our satellite, having its mechanical form factor in its own configuration, is able to do fast turns. So we're able to manipulate the spacecraft in space and turn it quickly during orbit. And then it settles very quickly, aims onto a target, and then also able to acquire the image very, very quickly. On top of that, one thing unique about ICEYE satellites as well is that we also have a feature for beam steering, right? We have a phase array radar, which allows the beam to be steered left and right. And this gives the satellite a lot more agility to take many more images at different angles. So of course, in more of the traditional kind of satellites with the other configuration, with a more circular antenna and receiver, it is not so agile. Just to give you some basic understanding, and this is of course available, it's fully available in terms of the details of the specifications of the product. Our spot, nominal spot product mode that we collect is at 5 by 5 kilometers. And one thing to note is that, you know, we only collect in X band. So, and our polarization is VV, right? So, so we may not have some of the processing capabilities with the other bands of satellite, right? So the penetration rate is different, and the reflectivity is also different with our bands, right, in the X range. I want to make a special announcement about SPOT, our new SPOT extended area product. What you saw just now was our nominal SPOT product, which still exists. But as of the 8th of December, I'm very glad to announce it here to the Remote Sensing Society in Indonesia that we in fact have something called the SPOT extended area. And I guess many of you will hear of it right now, because it was just launched anyway. So what's the difference between our nominal SPOT product? As I mentioned just now, is 5 by 5 kilometers in size, but our extended SPOT area right now is 15 kilometers by 15 kilometers. The ground resolution is still a 1 meter ground resolution, so you get just as good a resolution as our nominal product, but you get 9 times the SPOT area. Okay, so this gives you a lot more insight, a lot more data that you can actually manipulate and derive your insights. Okay. Now, I think we've done some research and we're quite sure it is the world's largest, very high resolution SAR imaging modes. So that, you know, you can look at the image on the left. While we are at 15 by 15, we're just giving you a relative size of the other alternatives in the market. And this image just shows you, you know, the kind of fidelity. Even though the image has been extended to, you know, 15 kilometers, you're still able to resolve all the features within your image, and then actually have multiple users in an urban environment, for example. So many of the customers who are looking at high resolution images sometimes have to wait, right, for multiple revisits of an area, let's say 15 by 15, for a second revisit, a third, fourth revisit, and then you sort of have to, you know, process it, auto-rectify it, stitch it together before you get the same size image. So in this case, you know, you not only save time, you know, you have less processing to do, and then you have the piece of image in your hands. And then actually, with the data, it really drives change, because with data sitting on your laptop, it really tells you that change has happened and therefore you need to act upon it. So of course, this is an example of the Grand Palais Museum in Paris in France. And that was a world's first. I mean, our SPOT extended area is a world's first. Now, another world's first, I mean, it was what ICEYE did when ICEYE managed to enable our small satellite, a new space satellite, for the first time was able to take a wide area imaging product, right? And this was also a world's first. So in fact, we've scored a few world's first, but I just want to tell you a little bit about this one. In our scan mode, we're the only small sat class of its kind, and currently still we hold the record, I believe, of being able to image 10,000 kilometers square in a single SAR image. And this is really excellent for monitoring, you know, sea routes, large ocean swaths, and so on. This is a bit of a detail about our scan product. It's at the resolution of 15 meters, which again is very, very reasonable. Again, our polarization is VV, and you can actually use it, for example, in the case of the Suez Canal. Now, what you see here is an example of ICEYE stretching its capabilities beyond 100 kilometers in terms of the image. What we've done here is actually stretched our scan image mode to actually 400 kilometers in length. Okay, but of course we are selling our standard scan image in 100 kilometers square by 100 kilometers square, right? So, but what it shows you here is the extent to which, right, an image can cover. Say in this case, it's the Suez Canal in Egypt, and you know, in the case of shipping companies, when they receive news of a vessel being trapped in the middle of the Suez Canal, on the right side of the image, you can see that, in fact, if you zoom in, there are ships actually queuing up to decide whether or not to go into the Suez Canal. And of course, with a large image in our scan mode, you can do things like ship detection, right? So this is an example of the Straits of Hormuz in the UAE, in which you can deploy or you can use image processing to recognize the ships within the area. Now, what I want to highlight about ICEYE's capability is that if you use our scan mode to detect ships in the ocean, and you want to then have a closer look at what you have detected, you can then also deploy our satellites in spot mode subsequently to look at the details of what you have actually identified in the sea. So it is sort of a tip and cue kind of operation that you can actually make use of, right? Because we have both the spot and scan mode. The next mode we have, as I mentioned earlier, is strip mode, and this is a 30 kilometer by 50 kilometer size. It's a very good resolution again of 3 meters by 3 meters. And this is an example of an image taken over Jakarta. Obviously, if you zoom into the actual data itself, you can actually see the vessels in the ocean. And strip mode is being used actually to look at very, very large areas in deserts or in vast areas where you want to look at whether or not some developments have gone on or have been taking place. So in this strip mode, it's very difficult at this scale, right, to look at the kinds of activities which are going on. But once you look at it, you look at there's some lines, and you want to zoom in. And here, when we deploy our spot imaging mode, you can actually see the kinds of infrastructure which is being built in this particular piece of desert land. So this is an example of spot mode. I beg your pardon, the strip. Sorry, it's actually a spot mode being deployed in the case of the Johor Singapore causeway. So now this causeway is a very busy causeway before COVID, because many of our fellow countrymen and our neighbors as well, we actually traverse through this causeway to come to work and to visit our relatives across the causeway and so on. So this causeway can be quite busy, and with spot mode, you can actually look at the intensity or the traffic jam or the traffic population of this causeway. Now, we also have something called daily coherent ground track repeat. It's a mouthful, but we want to give it a name that sort of describes our capability. And this is something, again, it's a world's first as well. So what do I mean by daily coherent ground track repeat? Now, for the first time in small satellite history, in new space history, this is a world's first capability to give you the ability to perform daily change detection with very high precision, right? And the detected changes, you can see in detail things like vessel movements, construction, infrastructure integrity, and so on and so forth, right? And spot detailed soil disturbance as well. So if you look at a piece of ground, and you know, maybe it's made of soil or gravel or sand, it's not so easy to spot the changes on a day-to-day basis, because even if you're there, visually you may not be able to see what has changed on the terrain. So how do we do this? So for the first time for small sats, we are able to very precisely put our satellites in orbit, right? And we acquire uniform SAR images, and then to allow extraction of information about ground changes, right? That you're not able to obtain by non-coherent imagery. So as the satellite flies in the same orbit, we take images of the same target with the same look angle and geometry, and then you can stack them together. So if you can see this particular animation, this is actually a compilation over several days of a port in Rotterdam in the Netherlands. And what you can see, obviously, quite a few changes here. On the top side, you can see it's actually a port, a container yard. You're just looking at the intensity image in this case, but then on the middle bottom, you can also look at the petrochemical tanks, and you notice that they actually do have changes in terms of their rooftops, which are going up and down. Here's a closer look at that. And so the georegistration of each of this image is highly precise. With this kind of information, you can actually, measure, for example, the amount of crude oil in the tanks on a day-to-day basis. You can look at the ships that come in and go out and make some kind of a conclusion about the activity of this particular petrol tank yard. Okay. Now, what can we do with daily coherent images? So I'm just going to show you very quick examples, and just to show you what you saw just now on the container yard. The components in red are the negative changes, and the components in blue are positive changes. So what this really means is that you have two images, one perhaps yesterday and one today. And what happens, what it means is that the objects in red were there yesterday and they're not there today. And similarly, the ones in blue were not there yesterday, but they were here today. So based on this kind of analysis, you can then make your own intelligence conclusions. Okay, so this is one simple way of amplitude change detection. It's simple and fast. It's a pixel by pixel comparison. You can mark those changes by colors, and then whatever remains, you can retain them in a single color, and so on and so forth. Okay, and this is a coherent ground track repeat data from ICEYE. So next, I'm going to talk about a little analysis that we've done. This is a volcano in Iceland. It's called the Fagradalsfjall volcano. It's a difficult name to pronounce, but it doesn't matter. So what happens here is that we've got the image, the intensity image, and then on the third image, it's going to be the coherent change detected image, right? So in between these two images, you can already see, and this is actually, if you look at the date on the bottom left, you can see that this is a change detected over 2 days, right? Because we're able to take an image every single day, right, of this particular area. And then if you compare the two images, this is actually the coherent change that has been detected. So very simply, the explanation is that this particular volcano data was acquired on 22nd of March, and after its eruption on the 19th to the 20th of March. All right. And with the daily ground track repeat capability, ICEYE's data can facilitate detailed change detection, right? In fact, if you compare the two images later, I'll show you the interferometry interferogram that you can use to look at very high accuracy changes, right? So again, the images taken on the 24th and the 25th of March, and this is in spot mode with a regular ground track repeat. And this is the interferogram of the same location using two ICEYE spot images, okay, with a 24-hour time difference. So, and we can do that with a strip as well, right? So again, it's a little bit more difficult to see the changes in strip because the resolution and the focal range of the image. But with coherent change detection, you can look at the areas which are not so coherent, and these are flagged out in the darker areas. And then you can perform an interferometric analysis using the two images as well. So very quick explanation. You know, I think the members here are quite familiar with interferometry. And so coming to Mount Semeru. So on the 5th of December, it actually sort of erupted, unfortunately. And we managed to task an image in two modes. The first here you see is actually a strip mode at 3-meter resolution. Currently, this mode, this particular image is not georeference. It's really a visual image. But subsequently, we also took a high resolution image with our spot mode. In fact, using our spot extended area. Now, we sort of passed this data to Dr. Augustin, and he so kindly put it through you know, the free snap processing software, and also compared it with the Sentinel data that he also got. And you can see the comparison. You know, our range, our ground range detected spot size is 50 cm by 25 cm. So you can actually see the resolution. It's quite good. In fact, I believe this is the path of the lava flow. Now we don't have a archive of the same area, so unfortunately, we don't have a before and after image. But if you were to pass this image to the disaster relief agencies, they can then do a damage assessment, and then they can perform their disaster mitigation relief efforts, right? Here again, another segment, this time a more higher altitude view of the same area. Again, you can look at the very detailed path. I believe this is also of the lava flow. And again, looking at the you know, the profile of the intensity of the image, you can see that it's very, very usable. So I hope that, you know, with images like this, your society and all its members. In fact, you know, I will give you a link to register to download the data as well of other areas or of say another area of interest that you would like to examine, right? Using our very high resolution images. I've actually come to the end of my presentation. Now, I know that there are many areas that was presented previously that I didn't touch on. Obviously, there's the possibility of flood detection. Definitely, we actually do have a flood solution that we actually do present to the governments and the very large organizations who use flood analysis. We also are able to supply data for almost any other use that you can think of using X-band. All right. So please go ahead and request for any sample data. Contact us. I don't mind, obviously, Dr. Agustin, if anybody asks for my email, please give my email to them. I'm very keen. ICEYE is extremely very keen to work with the Remote Sensing Society of Indonesia because we now have the possibility of collecting the entire Indonesia landmass in a very short time. We estimate that we could collect approximately 2.1 million kilometers square of data within about a month, right? So that is more or less the landmass of Indonesia. So if you want that, that's possible in strip mode. I also know that, of course, in the exclusive economic zone, in the maritime domain, there's a lot of need to also monitor certain areas for activities such as fishing, such as perhaps oil and gas activities, and so on and so forth, right? Indonesia has a lot of agriculture and forestry that is very key to the world's climate well-being, right? Of its preservation of climate well-being. And so with synthetic aperture radar, it is also possible to monitor deforestation and so on and so forth, of perhaps illegal encroachment, of maritime activity, and so on and so forth. So there's a lot to talk about. Unfortunately, I don't think I want to delve too much into so many of them because you guys are the experts of the downstream processing, and I'm very glad to have this chance to introduce to you ICEYE, its capabilities, and how we can move forward together with the Republic of Indonesia. Excellent. So with that, I'd like to thank you. This is just a summary of the main points that perhaps we'd like to emphasize. And I would like to hand over the time now to the Master of Ceremonies. Thank you very much.
Thank you, Mr. Joseph Yong. It's amazing, yeah, that most of these ICEYE products is the first SAR in the world, the first image in the world, that kind of claim that for us working on the SAR applications or SAR downstreams of research as well, this is quite amazing. Yeah, I mean, I know that we recently had our APSAR this year. We had the APSAR conference where mostly we talk a lot about synthetic aperture radar researchers presenting their research on that SAR applications. So now we're beginning to flow in terms of the application. We in Indonesia need this very much, especially for disaster. In my island, Sulawesi, we recently had floods everywhere. And one of the key solution for satellite images covering the optical image is this synthetic aperture radar, active remote sensing that can penetrate clouds, can have high resolution image. And this 0.5 centimeters is very high. It's really good to see if we can cover certain areas. Probably I have my own questions later, but I know the audience is here. I see Ibu Riza, Ibu Sasa is here. I hope she is still here. She is from Agriculture Minister. I believe she has some questions. And I guess there are also some audiences might be interested to go more for details, especially to Pak Yosef, Mr. Yosef, and of course there might be also question to Ibu Leila, who has given us also a perspective of SAR applications. So there you are, audiences, floors. If you have any questions, write down on the chat room, or you can just raise hands. We have sometimes for question and answer for both of our presenters, Mr. Joseph and Ibu Laila in our room. So, any questions? Yes, there is already one question from Mr. Shamani. This is directly to Mr. Joseph Yong. Are ICEYE imageries freely available to the public in real time? If it's not free, where can we get the pricing information? Now, this is what the public are requesting sometimes. I visited the website, but still, of course, not much information related to pricing. Yeah, maybe we have to contact you in person or to the administrative if we want to get pricing for the images. Or if there any research mechanism that allow us, a collaborative research mechanism, allow us to get these ICEYE imageries. That is from Mr. Shamani. Any more questions? If not, we might just answer this question first while waiting for the other questions. Would you like to answer this first, Mr. Yong?
Yes, thank you very much, Pak Shamani, for your question. Yes, we do sell the data commercially. We are also part of the community of suppliers to Copernicus program as well. So you could also get some data from there. But of course, there is the licensing terms that you just have to take note of it. Of course, most satellite image companies do invest heavily in trying to help the world get to see their own environment better. And of course, there is a cost to it. Yeah, so we hope of course to recoup that cost in our efforts to contribute to helping climate change and industry and commerce and so on. So please contact me directly, and I will assist you with it. Thank you very much.
Yeah, that's your answer, Pak Shamani, for that kind of request. We also from the university, Mr. Yong, needs this data. So far we have data from Sentinel-1. Yeah. Again, we have an issue of resolution. When we talk about satellite images, how detailed can we see things? This is what we consider. But then like Ibu Laila, she has, or maybe some of our researchers here, use this for interferometric. And this is probably my question is, will these images that you have, because it's only VV, what do you call it, propagation, yeah? There is no HP or HH. I mean, why is only VV? Maybe this is just to trigger discussion. Maybe Bulaila also has a question for this. Why only VV, for example? Yeah, the vertical pattern resolution. Yes. Maybe you can answer
Yeah.
this first while waiting for other questions.
Okay, so thank you for the question. I think it's a very fair question. I think it's a very good question as well. Now, if you look at the availability of the bigger satellites, right? So, you know, the satellites of current providers, they are very large. They're very large. Now, being a small satellite design, there is a need to balance, right? There's a lot of optimization that goes on into the design of the satellite. And I guess, and also a business decision as well, okay? So when the researchers and the designers and the commercial folks got together, and the founders, of course, in the company, to decide what kind of a satellite we put up there, they have to make certain decisions. And I guess to enable a second polarization would have meant more instrumentation, you know, the whole power supply chain, the processing capability, the batteries, which are pretty important, and so on and so forth. So the entire spacecraft needs to be optimized. So I guess it is a decision. And to obtain VV polarization, you then have to be sure that the backscatter will allow you with enough resolution and with enough intensity to give you the results that you want. So the amount of research and development that had gone in was substantial in order to decide whether to go for double polarization or single polarization, right? So I guess the answer was we would choose VV. I hope I answered your question there.
Yes, yes. Of course, that's after a long consideration, yeah, of the choices. Okay, ladies and gentlemen, I believe any of you, Mr. Hardy maybe, or Pak Agustan himself, is is curious about the specifications of this ICEYE, the availability. You know, it's amazing that it's daily coherent. You know, you can see it every day. You know, that kind of excellent availability. So please, Ibu Sasa, maybe I know she's here. She also work a lot on trying to map the agricultural aspects. Pak Hardi silakan Pak, atau Ibu Sasa kalau ada question kepada Pak Joseph atau Ibu Laila, nah masalah, please. This is a good opportunity to share and ask questions. Atau yang lain silakan. Ini nggak ada di chat, yang mau raise hand silakan. Saya lihat Pak Ketua juga lagi menunggu-nunggu question ini. Silakan Pak Hardi kalau ada, Ibu Sasa. Karena kalau tidak saya banyak pertanyaan sebenarnya. Ada many questions that we want to address Pak Joseph ya. Oh, Ibu Laila maybe has a question. Silakan Bu.
Okay, thank you Pak Ilham. Actually, I do not have so many questions, but a little bit curious.
Curious, yes.
Yeah, curious.
Yes,
about,
please address your curiosity.
Yeah, yeah. I have process or maybe just see my another team in my previous institute. They use TerraSAR X, which has similar characteristic with ICEYE, which is band X, and then they
X-band,
use X-band. Band X or X-band, and they used to monitor the building. Because, you know, it is a high resolutions, and then we can also get the point cloud to know the deformations of the building or to reconstruct some point cloud in the building. And my curiosity, it's I have already also an example when use this data for construction monitoring, or have not yet to do that.
Okay, that's a really good question, because with interferometry and with the intensity image, with the phase data, I think it would be possible. I would say it would be possible. Yeah, the thing about ICEYE is that, for example, we don't have many very significant case studies being published right now. We do have a lot of customers who have done their own findings. Many of them are keeping the results to themselves because they are very happy with the findings, and they perhaps are not so willing to share at this point in time. We have an analytics team in-house that has actually done many variations of possibilities of analysis, right? Including the creation of point clouds across the urban terrain, right? Using various methods, right? I think the methodologies are really up to your creativity. But what is more important is really the final end product, the final use and application that you want to use the data for. So I would say that try and get a hold of some data. I mean, please write to me. I'll give you the data samples, and maybe we could discuss how the new space that ICEYE is offering. So, for example, we have a daily ground track repeat, right? How that can come up with new insights, right, on a daily basis for a stretch of 30 days, for example, right? What is it that you can derive that you couldn't derive with the traditional satellites in the past, right? You had to wait for 7 days, 9 days or whatever to get the INSA, right? But now you have a whole series, right? So what can you derive? So we have some customers who are actually racing to derive new insights with daily collections. We just launched, as I told you, the extended high resolution 15 by 15 kilometers square. It's unheard of, right? So what if you stacked it together? What can you see over a 15 kilometers square with a very a piece of data that's very high integrity, right? Because it's collected in one go. You don't have to stitch it together. It's in one piece, right? What can you derive from there? Yeah. So really, it's only the beginning. In Indonesia, we've just only begun to engage with the whole of Indonesia, especially all the government agencies. I haven't even come to Indonesia because of COVID, but as soon as it's possible, I would like to meet all of you together. I know one of our consultants have actually gone to Jakarta already, but yes, let's do another session perhaps with a more deep dive, even with a case study, for as many areas as you want to do. So I would really encourage that. And even, you know what, I would encourage, whoever could make a decision to try to consider even acquiring 2 or 3 satellites from ICEYE to actually operate it over the whole of Indonesia, plus its maritime zone as well, because it is a very, very large place. And perhaps you have some occurrences or events that you may not want to wait, to get data on. So, yeah.
Related to that, actually, Mr. Yong, there is this international consortium on disaster. Is ICEYE also involving in this? Like when we have eruption, volcanoes, or maybe tsunamis, or maybe we have this, like in my area, we recently have a lot of floods, and as we agree that SAR images are very good in mapping the the puddles, the small details of where the water is actually gathered. So you involved is, I mean, is ICEYE already in here in this consortium or what?
Okay, so you're referring to ADP or something like that, Asian disaster preparedness.
Yeah,
agency
preparedness.
have.
Yes, as in preparedness.
That's one agency. I think for the moment we are not yet, but I'm sure we will be engaging soon. We are already engaged with FEMA in the US, right? And on the other hand, to bring this concept even further, we've actually developed our own flood monitoring solution, right? What we intend to do is to, because flood waters rise and then they subside, right? And many a time, disaster agencies and mitigation agencies want to know what is the height, the peak of the flood, right? As well as the insurance agencies, because this actually helps them with the compensation, insurance claims, damage assessment, risk analysis, forward risk analysis, risk planning for business and commercial, entities, very large corporations who want to invest. Say, for example, somebody wants to build Teslas in Indonesia, right? So they want to find a place which is low risk and so on. So we actually have we are building and implementing solutions like this. And we work hand in hand with the local government agencies, mapping agencies, and so on, to deliver a nationwide capability. And that is what we really want to do, especially to help out the Republic of Indonesia, because climate change is accelerating. It's not slowing down, unfortunately.
Yes.
Right? The impact, the effects of bad weather, unpredictability, unfortunately, it's accelerating. So the solutions that you implement need to be almost real time. So we hope to be able to assist in all manner of assistance. All right.
That's excellent. Yeah, sure. One question from Joseph related to the liquefaction. If you probably heard that last year, 2 years ago, we had this earthquake in central Sulawesi in Palu, and we have this not only tsunami but new types of disaster called liquefaction. Is there a possibility of ICEYE detecting this potential of liquefaction? And yes, it's been a serious problem since 2018. Yeah, that's true. You aware of this? If you want
yes,
to...
I know that Palu had suffered.
Yes. Is it possible to detect this liquefaction for this product?
Okay, I wouldn't be able to say offhand, but again, I think back to the same principles of change detection based on the coherence of the data and so on.
Okay.
I would say that it is a very good opportunity for the experts in your society to come together to make a study of this new phenomenon, right? If I think liquefaction is multifactorial. I think it has to do with a lot of the energy that is put into the earthquake, the properties of the geological strata, the composition of whatever is below the ground, and how susceptible it is to movement. And it behaves like liquid when so much energy is injected into the piece of land. So then you need to know what's the effect, because will it subside? Will it inflate? What is the result of it? So I would say it's a good, very good opportunity to embark on a study, and this will include even taking images currently, today, right, as archives of your particular areas of interest, so that you can compare them with future images, right? Now, I forget to tell you, and perhaps I should clarify, that all our satellites image the Earth based on tasking basis. So our satellites are not always on, as some of the satellites that you might know of. Okay, so it's all based on tasking basis. So I think it's a good time to identify perhaps
The
active
needs.
volcano,
Yeah,
active
volcanoes,
areas that you want to have,
areas.
areas that you want to monitor as well.
I see. Okay. Well,
Thank
that's
you very
quite
much.
clear. Any more? I think there is one more here. Was asking about the resolution and accuracy of the digital elevation model, because we probably knows that SAR systems can create this based on the face image. Yeah. So what's the accuracy and the resolution of this DM? Are you producing that or what? You can answer
Okay.
that. Yes.
Okay, so as again, I didn't approach this particular topic of value-added products on top of the so-called the basic product, which is the single load complex and the GRD formats. So currently, what we are doing is that we provide mainly the level 1 product, which is the SLC and the GRD. And we provide full documentation as to what it will consist of, right? Now, further processing to do DEM extraction, perhaps even to do auto rectification, we would normally then leave it to the users. One of the reasons is because, for example, if you want to auto rectify an intensity image, now we don't possess the accurate digital surface model or digital ground model of the area of interest that you have. We would just download a very rough SRTM or some model like that. And that would affect the accuracy of the final product, right? So normally what we'll do is we'll hand you the product, and then it's very easy to process as what Agustan will tell you. He's already processed it and rectified our product. So I think it's quite easy. It's easily ingested in Snap as well. And you saw my examples. In fact, those screenshots were from Agustan's desktop, actually. And so it's very easy and it's very fast. So I would say that with the kind of skills that are being among the members of your group, I think you have more than enough skills to make sure that the quality of the data comes out very good.
Would you like to comment on the Savior, the software that is also developed by ICEYE to Savoy? Savoy, is it the name of the software that we can download?
No, it is Savoir.
Savoir,
right?
sorry. Savoir,
no, it is not,
that's how you pronounce it.
Right.
Yeah.
It's not an ICEYE software. It's from France. We use that to look at the satellite operations and the orbital paths and so on and so forth.
Okay, I see.
Right. So it is something that you could license out yourself. So it's not from ICEYE really.
All right then. Okay, because
Maybe
it's in
I
your
have-
website. Yeah, Ibu Laila, please. Yeah.
Yeah,
Last
related with the softwares actually, because it's really amazing to know actually. Beside Snap, is there any also INSAR software that already try to use ICEYE data? Because you know that this is a quite new satellites, and then if there is some issue, and then mostly for the scientists that is related with the develop of SAR will post the issue in the forum, like maybe in the Snap or in the another open source software such as GMT SAR or maybe ITSA or Doris or something like that. So my questions is precisely what is another open source that we can also integrate with this ICEYE data? And is there already a forum, like a public forum that we can share? Maybe there is an issue when we do the rectifications or when we do some assembling with the with the pattern of the deformation or something like that.
Okay.
Yeah.
So
This, Dr. Yusuf.
yes.
Yes.
Yes, thank you for that question. So yes, it is something which we are, we want to make sure that whatever process that you want to run through, that perhaps you should also give us an idea of what you want to do, right? So now, for the there seems to be a lot of focus on INSAR in this particular discussion, but what we would like to do is to actually have a discussion with you as to what are the use cases that you would like to use, INSAR for, right? Now, being a new, relatively new player, right, in the new space, as a new space incumbent, right? We'd like to handhold our customers as to what they should or can expect with our daily ground track repeat. You've seen in the examples that I've shown you, interferometry is definitely possible. Coherent change detection is definitely doable, and so on, right? And we're using it, in-house with our own software. Now, what we'd like to do is to discuss with you, right? What you'd like to do with ground track repeat, and then we'd like to also handhold you and support you in the kind of projects, right? So it depends. So it depends on what ultimately your use case is, and I'd be very happy to, after this, perhaps go through with you what is your next interesting project. Okay.
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 All right.
Thank you very much.
Yes.
Thank you. Thank you, everyone. I believe we have no more questions at the floor, and I believe our time is also come to an end. We have been running for more than 1.5 hours. I guess if there's no more questions from the floors as well as in the chat room, I just would like to convey the message from the committee to Mr. Joseph. If your presentation is available to the committee, that we can share to the audience, so then we can have your contact as well for further collaboration or maybe further requests of images. I myself will surely write to you because I would like to test this kind of image. Mr. Agustan and some of our colleagues usually have trials on this, so we might be interested to go for that. Okay, so
Yes.
I have sent the link for the administration to those who need certificates or anything for this event. You're welcome to download. So, Mr. Joseph, you might have your final words to our audiences, and also Dr. Leila afterwards. Please, Mr. Joseph.
So thank you very much, Dr. Ilham. I really appreciate your time, and especially the committee. Dr. Noorlaila, I think your presentation was really amazing. Number of use cases and the amount of work you've done certainly attest to the capability of yourself and your team. Pak Agustan, again, thank you for receiving our data and processing the image for Mount Semeru. I hope it can contribute to the disaster relief and the relief efforts of the relief agency. And actually, for ICEYE, it is really a privilege to be able to speak to an audience such as yourselves, which is the Remote Sensing Society. It is a premier society in Indonesia, and all your members, certainly look forward to your committee to lead them forward in terms of technology, and in this case in particular, SAR technology. Now, ICEYE, as you can tell by now, intends to change and disrupt and offer better, faster, and even lower cost data, right? To allow nationwide change detection, right, to be observed and observed in almost real time. Now, I didn't mention that our time to deliver data after acquisition is less than 8 hours.
Wow.
Okay. Yes,
That's
it's less
amazing.
than 8 hours. It's published on our website. All right. So you no longer have to wait too long. Okay. Of course, if you take the entire Indonesia, you got to wait a bit longer, right? But
Yeah.
if it's like a reasonable AOI, I think it's possible. Okay. The other possibility is that because of the urgency of some of the use cases that I've heard about, it is even possible for you to even acquire, for example, satellite time, right? For example, at least 2 or 3 satellites from ICEYE, or even launch your own satellite and then deploy your own receiving ground station, right? Then the data will come down to you in a matter of minutes, okay?
Yes.
If that is so
Amazing.
required, right? If that is so required. And for the amount of investment, I think it'll be worth, for every dollar you can maybe perhaps get $10 in return from the various verticals, the various agencies, and all the industries that will benefit from acquiring such a capability. All right. The next thing and the last thing I want to say is that ICEYE is improving our satellites on a launch by launch basis. Okay, so we already have had quite a few launches. We've launched 14 satellites over 3 launches, and every time we iterate the satellite to have better solar panels, more capacity, higher frequencies, bigger capacities, batteries, and so on and so forth. Simultaneous acquisition and downlink capabilities, and so on. So our satellites are improving on a generation to generation basis. So so you have no fear of being missing out on the bleeding edge, because even our satellites that are in space are being upgraded as to its performances and the various systems on board. So we want to be able to walk hand in hand with you, because the requirements in your country, which is very large, are growing at an exponential rate as well, I would say. And so we want to be able to walk hand in hand with you to solve the most urgent problems, right, that you are facing.
Right. Sure.
Thank you very much.
Thank you, Mr. Joseph Ow Yong, for the sharing and everything that you have given us. Lastly, I would like to also give some time Ibu Laila to have her final words as one of our presenters.
Okay, thank you very much, Pak Ilham, and also Pak Agustan, to invite me with this, I think it's the 20 webinar, right? Yeah, for MAPIN. And then also thank you very much for Mr. Joseph that give us really deep explanations about these new satellites. Actually, for me, I'm really excited actually with your satellites, because you know that it is the high light. Actually, it's high resolutions in the TerraSAR X, so we can build or generate some InSAR techniques that cannot be done in the L-band or in the C-band, but with this X-bands, and I can compare maybe with the TerraSAR X. I hope that the price is maybe a little bit lower, I hope. And then there is also some a discount or maybe a free data for scientists. I hope in the future it maybe really help us to learn this environmental in Indonesia or maybe some other countries. So thank you so much once more again for Mr. Pak Ilham, Pak
Yes,
Agustan and
thank you.
the audience and especially for the Mr. Joseph. Thank you very much.
Thank you, Ibu Lela, for your time with us today. Pak Agustan, would you like to say something just to close up our webinar today?
Yes, Pak Ilham.
Yes.
One thing that I would like to highlight that ICEYE come from the startup company, so this is very important point.
Okay.
So it's come from the university. So I think
In
this is
Finland.
our future business actually, because now we are facing this trend of technology 4.0. So I think by understanding this kind of technology, startup company, collaboration with the university, I think we can establish many applications to utilize to all remote sensing data that are available in the market. So
yes,
yeah, let's collaborate together by strengthening our collaboration between the universities and the private sector and our community. So that's, thank you very much, Pak Joseph, and also
Thank you,
Bu
Pak.
Lela. Thank you, and Pak Ilham. Thank you, thank you.
Thank you, Pak Agustan, the chairman of Indonesian expert remote sensing expert in Indonesia. Ladies and gentlemen, that would end our webinar today. Thank you for joining us, and we'll see you again in the next event of MAPIN of Indonesian Remote Sensing Sulawesi. Thank you, and I would just like to remind Pak Joseph to share your presentation so then we can share also to the audiences. Thank you. I close.
Thank you very
Thank you
much.
very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much.
Okay, let's class. Oh yeah, don't forget to take pictures if you want, committee. I
Okay.
give it back
Yes,
to
please.
Pak Ibu Zilda.
Okay, let's take a picture together, everyone. In 3, 2, 1, and smile.
Okay.
Ternyata sama Pak Sony ya, Pak Ketua ini.
Okay, let's once again in 3, 2, 1, smile, everyone. Okay, thank you so
Okay,
much.
thank you.
Ilham.
Izin
Thank
live
you
ya.
very much.
Ya. Yuk.
Okay,
Thank you very much.
Assalamualaikum.
everyone.
Makasih ada Prof. Imran, saya lihat hadir ini dari UNHAS. Ada teman-teman dari Puslitbang Lingkungan, ada Pak Amaming, ada Ibu Sasa dan teman-teman dari MAPIN.
Ya.
Terima kasih
Tadi
ya.
juga ada Mbak Estu dari PVMPG, penguasa Gunung Semeru dia.
Oh, pantas ya. Ini kebetulan Pak Agustan saya share ke teman-teman Puslitbang LB lingkungan UNHAS. Jadi ada Prof. Imran saya lihat hadir ini menyimak.
Wah, terima kasih Prof. Terima kasih.
Karena kita banyak cari-cari data ini untuk banjir Pak Agustan.
Oh, siap.
Siap, nanti mungkin disupport ya. Ya.
Insyaallah.
Oh, ya, saya izin deh Pak. Terima kasih.
Terima kasih. Mohon izin juga.
Ya.
Tabet,
Assalamualaikum.
terima kasih.
Pak Hardi, terima kasih. Bu Silda. Terima
Thank
kasih
you,
banyak. Ya,
Pak.
Thank you.
Assalamualaikum.
Bye-bye. Thank you, everyone.
Thank you.
Bye-bye.
Bye-bye.
Thank you, sir. Thank you, doctor.